Hello, I'm Charles Rice, and this is
Shumail Gilani.
And we're two cloud solution architects in the customer success unit for Microsoft Education. We truly see our customer success as Microsoft's success. In order to achieve that, our goal is to create real value for our customers by using our products. What we mean is create value across the institution, from a very high level to faculty, staff, research, and last but not least, students.
I would say more than that, Charles, because if you see the customer nurturing cycle here, we start with engaging with the customers, transacting with them on each and every phase of their progress, and actually helping them in the adoption of the Microsoft Cloud much easier, much simpler, and a customer keeps getting the growth cycle increase every time we repeat this cycle.
Data science and research analytics are two really hot topics right now, especially in Azure. And what we've done to make sure that you're ready to go and start conducting that research in data science in Azure is we've created training videos, case studies, labs, hackathons, templates, and much more.
So stay tuned, there's lots of more fun coming on these areas. Myself, Charles, and my team are creating lots of material here. So keep watching, keep providing the feedback to improve all this content. Thank you very much for joining.
Thank you.
Hello, good morning, good afternoon, good evening, wherever you are. Welcome to our third video in this series for Azure for Data Science. Myself, Shumail Gilani, and we have
Charles Rice.
We both are cloud solution architects from Microsoft US Education team. We are very much excited here because we have very super talented two people from the students from UT Austin. Let them introduce themselves. So here you go.
Cool, thank you. I'm Prushan Shah. I am a UT MSBA student. MSBA is a Master's of Science in Business Analytics at UT. It's a fantastic program. And today we'll be going through some data in Azure Notebooks.
Hi, I'm Tiffany, and I'm also from UT Austin Business Analytics. And today we're going to start a project which is a flight data set. We're going to predict whether the flight will be delayed or on time. So,
and why you selected this topic? Are you tired of being delayed on the airports or what?
Yeah.
Exactly.
Isn't everybody? It's never fun, right? So.
Go ahead, please.
Yeah.
Okay. So let's first open our project. So we already have a project that running on free compute. So let's just going to open it. And I'll let Prushan to start about importing the data.
Sure. Okay, so what this data is a bunch of flight data. And every row will be, I guess, one flight. It'll have certain characteristics, such as where it left from, where it arrived, the departure time, how much it was delayed, if it was delayed at all, and certain things about that. So first we want to get the actual data. So in this first command, we're using the curl command, which is the client URL. And what it's doing is it's taking in this URL and it's outputting it as flightdata.csv into our notebook.
Oh, that's interesting. So in the previous video we did, instead of using curl, we actually went to file upload and brought in the data locally into the notebook's environment. But here you're using curl to traverse through the internet.
Right.
This is going to Azure Blob Storage, but it could be really any website.
Mm-hmm.
You grab data from that and bring it right into Azure.
Yeah. There's a lot of different ways where you can import data, and that's what's great about this.
Very cool. Very cool.
So next, we're going to import some libraries. First, we're going to import pandas as PD.
So what is pandas?
So pandas is a very popular tool with data scientists. It's a way to structure the data pretty much. And in this case, we're going to use a data frame. And a data frame is pretty much like a table. It's like a 2D table in which you can just store all your data as columns and rows.
Got it.
So we're going to store the flight data as a data frame. And we're going to just look at the first 5 rows just to make sure that it imported correctly. So as you can see here, we have 5 rows in just this view and 26 columns. In actuality, there's a lot more rows, but this is just the first view. So next, I'll hand it to Tiffany, who will go deeper into the data.
Okay. So actually before data scientists put the data to models and predict on it, we're actually going to clean it and prepare the data set first.
That's just so you want to avoid the cliche garbage in, garbage out.
Yes.
Make sure you clean out
That's
that
true.
garbage.
Exactly.
So if you run this cell, you can see that the data set contains 26 columns and more than 11,000 of rows. And next, this is going to show you what column is it, what column name it is in our data set. And next, we're going to look at whether there's missing value, because this missing value is a big deal for data scientists. We don't want any missing value. We want to ignore it or deal with it. So the output is true, which is telling us that there's actually missing value in our data set. Next, we want to look at how many missing value is within each column. The unnamed 25, this column contains more than 11,000 of missing value, which is exactly the same amount of our entire row of data set. So this is actually the mistake when we import data sets. So
It's probably just like an extra comma.
yes,
an extra-
exactly. So we want to drop this entire column. So now we drop this column and you can see it's gone. Next, so what data scientists will do is that they will only take out the columns they will need to do the modeling. So right now we're only taking the months, the day of months, the day of weeks, the origin, the destination, and the departure time, and last, the arrival delay to put in our data set. However, we can see that arrival delay, this column still contains 188 of missing values. So what we're going to do is that we're going to replace it by 1, which is telling us it is delayed. The reason why we're doing it is that missing value in arrival delay, we can interpret it as either the flight is diverted or it's never arrived. So we want to say that flight is delayed. So after we fill in an A of this column as 1, what we're going to do is next, we're going to deal with the departure time. Right now, departure time is containing lots of unique value, which is too complicated for us. So how are we going to deal with it? Is we're going to divide it by 100 and then run it up. By doing this, we're going to bin this departure time into 24 value, which is 0 to 23, which
Okay.
is
So you're taking a timestamp, like a date and time probably, and then changing it instead of all that. We don't care about all that information. We just want to care about the hour. And that's
Yes,
it. So you're
we
changing
only care
the
about the hour.
timestamp into 0 to 23, so midnight to 11 o'clock.
Yeah, exactly. So the last thing we're going to clean the data is that we're going to get dummy variables of origin and destination. And the reason why we're doing that is because it's better for us to predict on it.
Like for example, if you had a column of 1, 2, 3, 4, 5, with 1, 2, 3, 4, 5 being a certain destination or origin.
So 1 is an airport, 2 is another airport.
Exactly, and if that was how you had it, and then you predicted on it, you may get 1.5 or 2.5.
Sure.
It doesn't actually mean anything.
Mm.
So in this way, we are giving each of them a meaning.
So that's the end of cleaning and prepare for a data set. Next thing, we're going to do modeling on it. So one thing that we should do before putting into a model is that we want to separate the data set into train set and test set. And the common thing that data scientists will do is we're going to separate into 80-20. 80% in train set and 20% in test set.
Because you're going to train your model with 80% of the data, and then you're going to use that training to predict whether or not the model is correct with the remaining 20%.
Exactly. So now if we look at the shape of train set and test set, we can once again confirm that 80% is in train set and 20% is in test set. And then the last thing we're do is we're going to put it into model. And for this project, we're going to do random forest classifier. And the reason why we're doing classifier is that we're going to predict on a binary output, which is 0, 1, which means on time or delay. So in this code, we're going to first import random forest classifier from scikit-learn. And scikit-learn is actually a powerful package which contains lots of machine learning models, and we're going to pick random forest for this one. So this is the end of fitting our model, and I'll let Pushan to talk about how are we going to interpret the accuracy.
Let me say this is so cool. I mean, this type of cleansing was taking forever for us, and we were using multiple toolings here. It's one interface and all the cleansing is done.
Yeah, not only that, they're doing everything right now on free compute, so it's not costing anybody anything.
Wow.
Yeah.
Wow, amazing.
Awesome. Cool. All right, so now that we fit the model, we want to see how accurate the model actually is. So what we're going to do first is we're going to predict on our model using our test set. And we're going to get a model score. So this score is saying the accuracy of how our model does. So in this case, we get an 86% accuracy, which sounds amazing. But for this problem, it's not that reliable because we may have an imbalanced set where we have a lot of ones or we have a lot of zeros in our test set. What this means for this score in particular, what it's saying is how well are we able to predict if it's going to be on time. We're not looking at if we are predicting anything incorrectly. So we will do that in our next ROC score. So here, what we're doing is we're importing the ROC AUC score from sklearn, and we're going to use this to predict some probabilities. And then we're going to look at our score. So here we get around 67% accuracy. So the ROC score, it's taking into account what we predicted correctly and what we predicted incorrectly, while the previous score only takes into account what we predicted correctly. Obviously, what we predict incorrectly should also matter, which is why certain data scientists believe that this is more accurate and more of a better representation.
Right, so it's not only whether we're right, but whether we're right and whether we're wrong as
And
well.
wrong,
Because that
exactly.
obviously matters.
It can really affect how what kind of decisions you make.
Sure.
To go a little bit deeper into that, we're going to look at a confusion matrix. So we imported the confusion matrix from sklearn, and what we see here is our model predicting versus the actual results. So in the top left is if we predicted it was going to be on time and it was actually on time. And the bottom right is saying if we predicted it was going to be delayed and it's actually delayed. The other two, so at the bottom left and the top right, are if we predicted incorrectly. So the goal is to get a high number in the top left and a high number in the bottom right, and as close to 0 as possible for top right and bottom left. So we just want to be as accurate in predicting the actual result as possible. Next, we'll look into our precision and recall. So precision is of the amount of times that we predicted on-time arrivals. So let's say that our model predicted 4 on-time arrivals, but in actuality, there's only 2 on-time arrivals. That means our precision is 50%. So looking at this score, wow, we have a 99% precision score. And if we're looking at a recall score, if there are 3 on-time arrivals in actuality, and we were able to predict 2 of those, that means our recall score is 2/3. So in this case, our recall score is 0.865.
So 86%.
86%, yeah.
Cool, very cool.
So next we will go into some visualization, which I think is the best part. You can actually see what the data actually looks like. So first we're going to import matplotlib and Seaborn. So Seaborn just builds on top of matplotlib and has more enhanced features and can extend what matplotlib does. And so next we are going to plot the ROC curve as we had discussed before. So as you can As you can see here, the true positive rate is on the y-axis and the false positive rate is on the x-axis. And what this is saying is the true positive rate is saying that if it was a 0 and we predicted a 0. False positive rate is if it was a 1 and we predicted a 0. So we want to be above this dotted line,
Which is 50%, right?
which is exactly 50%. So obviously we want to be better than that. Okay, so next we are going to define a function called predict delay. And what this does is it takes in certain parameters such as the departure date time, origin, and destination. And what it will do is it will predict if it will be on time or not. So the probability of the flight being on time. So here, we're going to test that. So we're going to use that same function, and we're going to give a time, an origin and destination of JK and Atlanta.
So New York to Atlanta.
Yeah, and this is giving us a 0.6 probability of being on time. Then, if we look at the very next day, in October, for JFK to Atlanta, we're seeing a 0.8 probability that it will be on time. So every day will be different.
Yeah, exactly. So not only are you predicting delays between one airport and the other, but you're predicting delays from one airport to on a specific date at a specific time.
Exactly.
Wow.
Exactly. And then this is a completely different route. So this is Atlanta to Seattle. And here is 100% a probability of arriving on time. So what's really cool is that we can take all of these and we can put it in a graph. So what we're doing here is we're looking at JFK to Atlanta from October 1st to October 7th, and we're seeing the probability of being on time. And as you can see, you should only fly on October 4th in this case.
Wow.
Because then you can almost guarantee that you will be on time. If we want to go into another route, looking at Seattle to Atlanta, we can see here that the best time to actually fly for one day would be at 9 a.m.
Okay, so the first graph was obviously different cities, but also just days you should fly.
Mm-hmm.
This graph is 2 different cities, but the time of day.
The time of day.
Okay,
So just
awesome.
imagine how powerful this tool can be when you can go deeper and deeper into the data and understand more and more about it and just create great business insights from this.
That's awesome. Not only that, so like the best thing about this, I think, by far, is that you didn't use one tool. Like you also didn't use Azure specific tools, right? You didn't use Azure Machine Learning Services at all. You used an open library, a free library that you brought in, and then you use many different tools to iterate through it to get the best model. So you're not stuck with one route, and you had a lot of flexibility, and it was free.
Exactly.
Right now.
Exactly.
Obviously, you can spin up a data science virtual machine like what we covered in the first video to give it a little bit more horsepower if you had a bigger data set, if you're doing more advanced algorithms that you had to compute through. But for this purpose, I think the free compute was more than sufficient.
Yeah, and actually in this data set, it only contains 5 cities. Imagine if you included all of the U.S.
Well, you could do the globe, right?
The entire globe, and just imagine how big that data set would be,
Yeah.
and you would need a cloud service or some kind of VM in order to do that.
Right.
Wow.
Awesome.
Simply wow. I would try myself, especially the cleansing part and then modeling the part. I'm super excited. I will try myself.
Make sure you run this before you fly anywhere.
Yeah, perfect. Thanks, Tiffany, for joining. Thanks, Pushan, for
course.
presenting all this stuff. Thanks, Charles, for joining. And thank you. Please go try all this stuff yourself. We have another video coming, which is part 4 of this video series. Charles, you want to describe anything about that part 4?
This is the third video. The first video we did was the introduction to Azure Notebook. So it basically gave you everything you need to do up to this point. So if you haven't watched that yet, go back and watch that. Second video was trying to predict climate change and see what's going on there. This video, obviously, flight delays. The fourth video, rather, is a sentiment analysis, right? So we'll have text, and we'll be able to gauge the sentiment of the text based using Azure Notebooks and machine learning.
Perfect. Thank you, everyone, for joining today, and thank you for joining.
Thank you.
Good luck.
Artificial intelligence is fueling the next wave of transformative innovations that will change the world. With Azure AI, our goal is to empower organizations to apply AI across the spectrum of their business.
We are developing the tools to enable anyone, not just PhDs or researchers, to harness the most powerful AI supercomputers in the world in order to overcome their problems, no matter how complex.
We are moving beyond big data and machine learning capabilities to be able to infuse cognitive capabilities.
I think Azure for research with the cognitive services and the machine learning capabilities there are phenomenal to help researchers actually maximize their time. They spend less time building and maintaining systems and more times actually implementing and doing the studies that are necessary for this research.